In early 2026, the technology industry abandoned the chatbot. We moved away from reactive interfaces where you wait for an answer, shifting to proactive, background-running digital workers capable of multi-step execution. Look at this adoption rate. An open-source AI agent called OpenClaw dwarfs standard software releases, accumulating nearly 250,000 GitHub stars in weeks. Right as that line went vertical in February 2026, Anthropic and Perplexity released their own proprietary corporate solutions. The market fractured instantly. Because these tools operate so differently, choosing an AI agent today means locking yourself into a specific computing architecture. The entire ecosystem is currently defined by a single trade-off: access versus isolation. If you give an AI root access to your machine, you gain massive workflow automation. The agent can write code, manage your files, and operate your software. But doing so introduces a severe security risk to your personal data. On the other hand, if you isolate the AI in a secure cloud environment, your local data is protected, but the digital worker is now permanently blind to your native operating system. There is no universal best option. The architecture you choose determines whether your digital worker acts as a force multiplier or a critical security liability. OpenClaw represents the extreme end of local access. It is a massive monolith built on a 500,000-line Node.js framework. Its raw power comes from its unrestricted access. The central OpenClaw node creates connections that extend straight to your operating system. It can autonomously drive a web browser, execute scripts in your terminal, and read your local system files. But that architecture creates severe security risks. Because OpenClaw integrates with public messaging channels like Telegram, a malicious prompt injection can travel down an external connection, bypass your system defenses, and compromise your local files. This risk extends to the Claw Hub Skill Registry, a single malicious community plugin downloaded to expand your agent's abilities can silently exfiltrate your private cryptographic keys in the background. Developers reacted to this vulnerability by building MiniClaw. Instead of a massive monolith, MiniClaw is a hyper-minimalist micro-kernel. Rather than running as an independent robot, MiniClaw embeds directly into your existing developer workspace using the Model Context Protocol, or MCP. MCP is a standard that allows different AI models to connect securely to local data sources and development tools. To manage operating costs, MiniClaw uses an adaptive context engine. When you enter a heavy heads-down coding session, the engine automatically prunes the context window to prevent wasting expensive API tokens on unnecessary conversational data. For security, MiniClaw relies on a strict cryptographic whitelist. The AI is permitted to read your system state, but it is physically blocked from executing destructive terminal commands. While this microkernel is significantly safer than OpenClaw, it still operates within a shared memory space on your host machine. That means a theoretical attack surface still exists. Native host execution, whether unrestricted or carefully whitelisted, requires you to accept a baseline level of risk to your local data. If you require local execution but refuse to accept those security risks, the market developed NanoClaw. NanoClaw operates on a defense-in-depth architecture. It forces every AI task into a disposable Linux or Apple container. All processing happens inside this sealed box, entirely separate from your host operating system. If the AI hallucinates a destructive command, or if an attacker successfully hijacks the agent, the damage is trapped within the ephemeral container. Your primary hard drive remains untouched. It also features per-group memory isolation. This structurally guarantees that sensitive data discussed in a private channel cannot leak into the context window of a public coding channel. Inside these secure channels, NanoClaw can run agent swarms. It orchestrates multiple specialized Claude instances, allowing them to collaborate on complex research and coding tasks simultaneously. The primary limitation here is vendor lock-in. NanoClaw is strictly built on the Anthropic SDK. You do not have the flexibility to route tasks to cheaper open-source AI models. Strict containerization solves the local security crisis, but you trade away multimodal flexibility and restrict the AI's vision of your system. Beyond open-source frameworks, the heavily capitalized enterprise market took a different approach. Anthropic introduced Claude Code Remote Control. This is a hybrid teleoperation model. The actual code execution and file manipulation stay strictly on your local machine, but operational control is bridged to your mobile device. This diagram shows the security of that bridge. It uses outbound HTTPS polling only. The local machine reaches out to check for commands, ensuring no inbound network ports are ever exposed to the public internet. But this architecture creates severe process fragility. If your local laptop goes to sleep, or if you lose internet connectivity for 10 minutes, the remote session permanently terminates. At the opposite end of the architectural spectrum is Perplexity Computer. It abandons local hardware entirely and operates in the cloud. Perplexity's core innovation is multimodal orchestration. It takes a complex goal and autonomously delegates subtasks across 19 different frontier AI models, leveraging the specific strengths of each one simultaneously. This cloud-native architecture requires a steep enterprise budget. Access requires a $200 per month subscription, which grants a finite allocation of 10,000 compute credits. And because it operates autonomously in the background, you face the risk of runaway credit burn. A failed logic loop can quietly drain you entire monthly credit allocation on broken tasks. Paying for a premium enterprise subscription offloads the friction of local hardware management, but you are replacing hardware security risks with substantial financial liability. Choosing an AI agent based on viral hype will lead to system failures. You must base your decision on your operational boundaries and your risk tolerance. This decision tree shows how to navigate your options, starting with whether the AI needs to touch your local files. If you require absolute autonomy, want to build custom skills, and accept high security risks on your machine, follow the path for the tinkerer. Your match is the OpenClaw monolith. If you demand local execution but refuse to compromise your host operating system, follow the path for the security-conscious developer. Your match is the containerized NanoClaw. If you are a professional engineer optimizing for ROI on large proprietary codebases and you need massive token context, pay the premium for Claude code. And if you are an enterprise researcher who is budget agnostic and you need deep research generated across multiple models without touching terminal commands, subscribe to Perplexity Computer. The AI will not replace you, but forcing an incompatible agent architecture into your daily workflow will paralyze your productivity. Look at the constraints of your environment and choose the digital worker that respects your boundaries.